Hi, this is just a quick recap of some knowledge about angles which you will need to have by the end of year 6 and going into year 7. We're just going to go through very quickly the sum of the interior angles of triangles and quadrilaterals, and we're going to look at some angles around a point and when straight lines intersect each other. It really is just a brief recap. You'll see in each section there are applets which I've made on GeoGebra, which if you follow the links you'll be able to go and have a go yourself. I really recommend having a play around on the app itself. It's completely free and it's a really good way of building up an understanding of geometry, angles, side lengths, everything you can imagine. There's some great tutorials on there. There are 4 types of triangles and these can be classified according to their angles. To start off, we have an equilateral triangle. That means all sides are the same. Because all the sides are the same, the angles stay the same. And it doesn't matter how big or how small this triangle is or where it's rotated, the angles will always be 60 degrees each. So all the sides will be the same, all the angles will be the same. An isosceles triangle only has 2 equal angles, the 2 blue ones marked here, and the sides next to them, here and here, are also the same size. Because this triangle has been drawn inside a circle and the apex is at the centre, I know that both sides going from the centre of the triangle to the circumference are the same length, which means that the 2 angles will also be the same size. Doesn't matter where I move these points, those 2 angles which are blue will stay the same. A right-angled triangle can be an isosceles triangle or a scalene triangle. All it means is one of the angles is a right angle. And interestingly enough, if you draw a triangle by going from one side of a circle through the centre to the other, the third point, it doesn't matter where on the circle it is, it will be a right angle. So you have a right angle triangle. When both sides from the right angle are the same length, it's an isosceles. If all the sides are different lengths, it's a scalene, which brings us to this last triangle. So a scalene is any other triangle where all the sides, and therefore all the angles, are different. If you want to have a bit of a play around with this model, if you go to the site written at the top of the browser, if you type that in, you'll be able to have a go on this applet for yourself. The angles of any triangle, the interior angles, always add up to 180. So I've created this little applet just to show you why that works. So I've got a triangle here. I can make this triangle any size and shape I like. And using the sliders, I can get the triangle to rotate itself around the sides like this, so that you can see. So I color coded the angles. So this pink angle is now up next to the blue one, and the green angle has rotated and is also now next to the blue angle. And you can see that they join together to make a straight line. You can also see that on the written bit here, it tells you A is currently 69 degrees, B is 40, C is 71, and those add up to 180. And I can now move this triangle around anywhere I like, and those angles, as much as they change, will always add up to 180. Again, if you would like to have play with the applet, just type in the address in the browser above. The angles of a quadrilateral sum add up to 360 degrees. We can prove this by, you can take any quadrilateral you can draw, and by drawing a line from one corner to the diagonally opposite corner or vertex, you'll make 2 triangles. So here I've got a quadrilateral. Again, I can move this around to make any kind of shape I like. And I have set up this so that I have a translation of the same shape attached through one of the vertexes. And again, using the slider, I'm going to rotate it so I can move the other 2 angles. So I've now got the 4 angles of my original quadrilateral represented around a point, and you can see that they add up perfectly to 360 degrees. It tells you the different angles here, and the sum is shown at the bottom. This is going to be the same. It doesn't matter how I change this quadrilateral. I'm going to end up with 360 degrees at the same time, at the center of this point here, and the sum of the angles will be 360 degrees. Again, follow the link in the browser and you can have a go for yourselves. We know that the sum of angles on a straight line is 180 degrees. So it makes sense that the angles on the other side of the straight line are also 180 degrees. If we cross one line with another straight line, we end up with pairs of equal angles. So if you look at the pink and the violet angles, we've got 125 and 55 along the line AB, then you can see they add up to 120. And you can see that on the line AB, if you look underneath it, we've got the red and the orange angles. The pink and the red are the same size, and the violet and the orange are the same size. Now, if I decide to move and alter the angle of the line which is crossing AB, so the line CD, I can change the angles in any way I like, but because of the relationship between the two straight lines, I'm always going to end up with opposite equal angles, and this is often called vertically opposite angles. Even if the angles are horizontally opposite each other, we refer to them as vertically opposite. As always, follow the link in the browser if you would like to have a go yourself. It then follows on that if a pair of parallel lines is crossed by a straight line, you're going to see a repeat of those angle relationships. So all the angles coloured green are equal and all the angles coloured pink are equal. We call these complementary and supplementary angles, and you'll often come across puzzles where you're asked to find out one of the missing angles when you're in one intersection when you're only given angles on the other intersection. By reasoning about the straight lines and the fact that they're parallel crossed by a straight line, it's quite easy to work out which angles are going to be equal or not. This only applies if all the lines are straight, which in maths lines are always straight, but they must be parallel for the relationship to exist.